Right now, you're probably sitting somewhere comfortable, a quiet room, a steady chair, but if we rewind the clock, the exact spot you occupy was a roiling ocean of magma, bubbling at 8,500 degrees. Fast forward, and that same location, your room, was later buried under miles of solid, lifeless ice. We tend to picture Earth's 4.5 billion-year history as a slow, gradual calming down, a hot rock slowly cooling into a gentle green oasis. The reality is far more violent. The perfect temperatures, the breathable air, and the solid ground we rely on were accidentally engineered by 3 distinct, world-ending catastrophes. These disasters functioned as mandatory construction phases. They were the mechanical resets required to transform a toxic rock into a habitable world. Our solar system began as a massive, exploding cloud of gas and dust. As gravity crushed this debris together, the early Earth formed. It was a toxic, molten wasteland, completely hostile to any form of life. Then, a rogue planet, roughly the size of Mars, named Theia, slammed directly into Earth. The massive impact blasted billions of tons of rock into space, which eventually clumped together to form our moon. Meanwhile, the heaviest, highly radioactive metals from both planets melted together and sank straight down into Earth's center. This dense concentration of radioactive iron and nickel became our core. It gave Earth the powerful gravity needed to hold on to an atmosphere, and it generated a massive magnetic field, a shield that deflects deadly solar radiation. Protected from the sun, the planet began to cool. For millions of years, vast storms of meteorites battered the surface. These space rocks were packed with salt, minerals, and frozen water, slowly filling the early oceans. Deep underwater, heat from the core escaped through volcanic vents, mixing with this mineral-rich water. In that extreme, boiling chemistry, the very first microscopic organisms spontaneously came to life. The violent impact of a rogue planet gave us gravity, a protective shield, and deep oceans. Without that collision, Earth would have remained a dead, sterile rock. Those early microbes thrived in the oceans. Over millions of years, they began consuming minerals and pumping out a byproduct, oxygen. But this new gas was highly reactive. The oxygen bonded with iron in the oceans and the atmosphere. This triggered heavy, toxic acid rains and stripped out the carbon dioxide that had been keeping the planet warm. Temperatures plummeted. The oceans froze over completely, encasing the entire globe in miles of solid white ice. The microbes nearly engineered their own extinction. But deep underground, that radioactive core was still burning. The trapped heat built up incredible pressure until massive volcanoes began punching straight through the miles-thick ice sheets. These eruptions pumped enough carbon dioxide back into the air to melt the glaciers, allowing oxygen-producing plants to flourish in the newly warmed oceans. Over thousands of years, this surge in oxygen created a thick ozone layer, finally shielding the land from radiation and allowing giant trees and mosses to survive on the surface. That severe chemical crash and global freeze forced simple ocean bacteria to adapt, driving the evolution that eventually carpeted the continents in green forests. By the time the massive supercontinent Pangaea split apart, Earth was a humid, lush greenhouse. It was an environment perfectly suited for massive dinosaurs, who maintained absolute control over every ecosystem. Then, a rock larger than Mount Everest struck the coast of modern-day Mexico at 80,000 kilometers per hour. The impact released the explosive force of 100 million nuclear bombs. A superheated shockwave incinerated everything in its path, throwing so much pulverized rock into the atmosphere that it blacked out the sun. The surface was plunged into a dark, freezing winter. The plants died, the food chain collapsed, and the ruling dinosaurs starved. But down in the soil, away from the freezing surface and the scorching fires, tiny rat-like mammals were safely insulated. They scavenged on insects and roots, waiting out the long dark. Those tiny scavengers were our direct ancestors. If that asteroid had missed Earth by a fraction of a degree, the giant reptiles would have kept their hold, and mammals would have stayed at the very bottom of the food chain. Millions of years later, the climate shifted again. Ice caps formed at the poles, drawing moisture out of the air. The dense canopy forests of Africa withered, leaving behind open, dry savannas. The apes living in those disappearing forests lost their food supply. To survive on the open plains, they had to stand up on their hind legs to see predators over the tall grass, and they had to travel long distances to hunt. Freeing their hands triggered a surge in brain volume and technical skill. They began shaping stone into blades, capturing fire to cook meat, and developing language to pass their knowledge to the next generation. In a geological blink of an eye, a small, terrified creature hiding in a burrow evolved into the most dominant species the entire planet has ever seen. Every step of our existence, from our heavy iron core to our bipedal stance, is the direct result of a catastrophic disaster forcing life to adapt or die. It took 4.5 billion years of chaos to forge a planet stable enough for us to build our civilizations. Yet, in less than 2 centuries, we are undoing that delicate balance. By burning fossil fuels, we are acting exactly like those ancient volcanoes. We are forcefully pumping billions of tons of carbon back into the atmosphere, rapidly heating the globe. Earth has survived every reset we've seen, from boiling magma to global ice. But those transformations took millions of years, allowing life to slowly adapt. We are now compressing that same planetary change into a single human lifetime, engineering a shift so rapid that we risk becoming the only species to ever trigger its own extinction.